take a moment and reduce these fractions. Go ahead and pause the video to do that. These are some fractions you're going to want to recognize readily, and they come up in your life. So 30 degrees out of 360 is the same as the distance between the numbers on the clock, because a full circle is 360, and there are 12 numbers on the clock. Each angle, each central angle made by the hour hand and the minute hand would measure 30 degrees. Pizzas are usually cut into eighths. You cut it straight across, straight up and down, and then make an X through that. That gives you 4 pieces on top, 4 pieces on bottom, or a total of 8 pieces. The central angle for each of those pieces is 45 degrees. And if you take a cake and cut it for only 6 people, then each of those central angles would be 60 degrees. 30, 60, 45. We've seen these angles before. We will keep seeing them. This is a meme I found online, but it's very relevant to today's lesson. Sometimes you get a pizza that's smaller and they cut it into fewer pieces. Sometimes you get a pizza that's larger and they cut it into more pieces. So which is the better deal if you're buying the pizza by a slice? Well, you have to consider the radius, how big is the pizza, and you have to figure how much of the pizza are you getting. We just looked at it and discovered that a 60-degree angle, a 60-degree central angle, would work if you had 6 pieces. But if I had 8 pieces, the arc length would be 45 degrees, because 8 times 45 would give me 360. So you can pause the video and read through the solution to this problem. Pizza on the left, you know the radius, so you know the area of the whole pie. You know that a slice is 1/6 of the pie if the arc is 60 degrees. So, and we know the price. So 6 slices at $1.50 is $9 per pizza pie. And then you can take the price and divide it by the square inches to get an approximate cost per square inch. You can do the same thing for the pizza on the right. Radius is 9. If it's a 45-degree slice, there's 8 of those slices. So you know the whole cost of a whole pie, and you can then calculate the cost per square inch. So which one's a better buy? We also see pie charts a lot in math, in statistics. So if you do a pie chart, each sector has a different color, represents a different thing. We call them in math, the division of a circle, those division pieces are called sectors. So in this case, you've got 20 students randomly have been surveyed. These are the results of those 20 students, and we want to generalize those results to the entire school. So you basically apply the percent or the fraction of the school, the fraction of the pie, to the entire number of students in the school. So what about action movies, my favorite kind? 25% of the pie, or 1/4, would choose action movies. So those are the key terms to get out of the reading of the word problem. And so you just find 1/4 of the total circle, and that'll give you the answer you're looking for. If the whole school is 1,800 students, 1/4 of them would be 1/4 of that number. You multiply those, which is essentially taking this number and dividing it by 4, and you get 450 students. Now you have some notes. Pause the video and copy this down. So the area of a circle we've already reviewed is pi r squared. But the area of a sector of the circle, that's just a fraction of the whole circle. What fraction? However many degrees the central angle is out of 360, that gives you the fraction. You multiply that fraction times the area of the whole circle, and that will give you the area of that pie slice, of that sector is the correct term. So let's do an example. Pause the video and copy this down. So we're going to give our answers in terms of pi, or we're going to round it to the nearest hundredth, which is 2 decimal places. We want to find the area of sector HGJ. We know the degree measure, and we know the radius. So we're going to use the formula that we've been given. The formula tells you that you take the area of the circle and you just multiply it times the fraction. Where do we get that fraction? Well, m is my central angle and r is my radius. So you just plug those in, square the 12, multiply, simplify, and we get our answer. And remember, area is square units, so always watch for units on any measurement to know what your answer should be for units. Let's do another example. Pause the video and copy this into your notes. In this case, my central angle is 120 degrees, and my radius is 4. So again, I'm going to use that same formula that the area of a sector is the fraction of the circle times the area of the circle, the formula for area of a circle. Well, if it's 120 degrees, I put 120 over 360. Hopefully you can recognize that that is 1/3. It's the same as 12 over 36, which is the same as 6 over 18, which is the same as 1/3. So you plug in the radius is 4. You simplify the fraction. You can go ahead and square the radius and multiply the numbers on the right here are really over 1, so they become on the numerator side of the fraction. And you can leave your answer like that in terms of pi. And they didn't give us units, so we'll just say units squared, because area is always in square units. Pause the video and copy this. So notice my central angle would be 45 and my radius is 18. So I'm going to take the formula for the area, which is the fraction of the circle times the area of the circle, plug in the 45 degrees, for that's going to be the fraction, plug in the radius, simplify the fraction, always a good habit, and you're going to want to come to recognize that 45 goes into 360 8 times. You can square the radius, and then recognize how to multiply fractions with whole numbers, even if they're irrational. And when you divide that, you get a decimal with pi. And since you've already got a decimal with pi, you might as well multiply them together. But remember, this is rounded off, so I have an approximate symbol. And this is rounded to the hundredths place because I have 2 decimal places. And the area is square units, where my units that were given were yards. Pause the video and copy this one down. And this is one you could probably figure out. I bet you know what fraction of the circle 90 degrees is. Well, 90 degrees out of 360 is 1/4. You plug in the radius is 16 and you square that, you get a big number, 256. You multiply your fractions together, you get another fraction. Divide the numerator by the denominator. You can leave your answer in terms of pi with centimeters squared, or you can give me the approximate answer. This one is not rounded like it should be to the hundredths. This is rounded to the full unit of centimeters or centimeters squared. Pause the video and copy this down. Now ask yourself, what is the radius? And what is the angle that would be the central angle for this purple sector? Well, this central angle looks like this makes a straight line. This is the diameter. So if this is half the circle, then this is 180 degrees. If this part is 120, the purple angle would be 60. The central angle would be 60. And the diameter is 26, so the radius would be half of that, or 13. So you need to identify the radius and the central angle in order to use the formula that we were given. The formula is the fraction of the circle times the area of the circle. Well, 60 degrees out of 360 is 1/6. 60 goes into 360 6 times. The radius we decided was 13. You square that, you multiply these fractions, you simplify it. You can leave it in terms of pi, or you can turn it into a decimal. But either way, you want to identify the units squared. I should have written meters squared on this answer as well. Now, This is another concept. This is focusing on just the pie crust, just the arc length, just that piece of the circle that's here. How would we figure out how long this sort of a arc is? And there's many applications with satellite dishes, contact lenses, lots of things that have just an arc length, and we want to know the length of that arc. The process is the same, only now we take the circumference multiplied by the fraction or ratio that compare the central angle to 360. Well, that's a lot of words. Plus, this idea of distance around the arc sometimes confuses people. We're not going all the way around the sector. We're really just going along the arc, just this darker part right here. So the formula is that the arc length is the fraction times the circumference, 2 pi r, or 2r pi, or diameter times pi, because 2 radiuses is a diameter. So let's look at an example. Suppose I have this circle with a radius of 2, and I want to know how long is this arc length from A to C. Well, arc AC, its length is going to be the fraction of the circle times the circumference of the circle. If my radius is 2, then my diameter is 4, so my circumference is 4 pi. Now 72 goes into 360 5 times, so this fraction will be reduced to 1/5. And then you can multiply these two together properly, leave it that way, or you could give an approximate decimal version of the same answer. So here's another one. Pause the video and copy this down. So here my central angle is 120 degrees. Well, we already saw that before, where 120 over 360 simplifies to 1/8. And here, oh, it did not tell me that my radius was 8. Somewhere I magically found out that my radius was 8. I think that information's missing right here. But if my radius is actually 4, then my diameter is 8, excuse me. So the radius is 4, the diameter is 8. You get 8 pi times 1/3, or 8 pi over 3 units, whatever the arc length is.